In this video, we are going to talk about angle of elevation and angle of depression. These are the terminologies that often come across when we are solving the word problems in trigonometry, where you need to draw a right angle triangle and solve the problem. Let's have a look at an example. That, for instance, we have um, a big building. Let's say this is a big building, high-rise building, and an observer. So this is a building. An observer is standing on the road. This is the observer and observing something here on the top of the building, so in the roof, right? So what is the angle of elevation? You can see, you in order to look at there, your vision should be upwards, right, like that. So you are basically making an angle, your vision, like to see upward direction, and angle is always from the horizontal line. So it means this is called angle of elevation. So elevation, angle of elevation means measured up the angle. I can just make a short note, from measured up from the horizontal, right? Okay, measured up from the horizontal. So you see always the angle will be at object, so at that point where the observer, where the observer observing, so that point would be the angle, and angle always would be the object or whatever in there with the horizontal line, right? Now then, how about the angle of depression? From the term itself, you know the depression is means going down, right? So it means measured down. What happened if, let's say, you have an object, now observer here, observer is just sitting in the roof, okay, and then looking at something who is walking, or something walking through the road, or someone is standing in there, okay. So you are observing here, so observer observing something on the road here, right? So in that case the vision is that direction, right? So your vision will be that direction. So again the angle will be at the observer at that point, but angle at observer but with the horizontal line. So in this case, that is the horizontal line, the angle will be down, measured down from the horizontal line. So always the angle would be from the horizontal line, from the horizontal line. So in this case, measured down, angle should be measured down from horizontal line. Okay, now if you look at this, the two angles, angle of elevation, angle of depression, on the same diagram, you can relate them. Then both angles, you see, angle of elevation and angle of depression, they are same. Why? Because you see, this is, these two lines are parallel because they are horizontal lines, and these angles are called the alternate angles in the parallel lines, so they are same. And then also these two angles are acute angles, so angles are same and angles are acute. And it is very important to know where the angles is and what is the, which one is the angle of elevation, angle of depression, and we can see that very soon when we are solving problems based on these terminologies. And now also, when we will see this kind of problem, we have to visualize, because the wording problem is probably the most of the time the diagram will not given, so you have to visualize and draw the diagram and draw a right angle a triangle and use the trigonometric ratio to solve the problem. And let's see what we can do when we are solving the problem. Okay, let's say that we have an example here. The altitude of an airplane is 500 meters and the angle of elevation from the runway to the airplane is 15 degree. Find the horizontal distance from the airplane to the runway to the nearest meter. So you know the altitude of an airplane is 500 meters. So if I said this is our airplane, which is A in that position, so and that altitude means from that ground the height of that airplane is 500 meter, right? um, and the angle of elevation from the runway, so it means our observer is on the runway here, so this is our observer. So let's say it's our O, okay. O is for observer, okay, and then from that runway here, it's making from observer, always angle is at observer, 15 degree to the aeroplane. So observer is standing here and it is making 15 degree. So the angle is 15 degree. Okay, so angle of elevation from the runway. So runway is here. So this is our runway. The observer is standing here to look at the aeroplane A. Let's say this is our, now you see, so from this information we need to draw a right angle triangle, as I said before. So we are making a right angle triangle. If you connect this observer with the aeroplane, and then you can say this is our, for instance, B. So AOB is our triangle, and these two information is given, angle and the height, right? And it's asking find the distance from the aeroplane to the runway to the nearest meter. So it's a basically horizontal distance from the airplane to runway, the this observer, the horizontal distance. So it's asking for x. Alright, so now from this diagram we can just use the trigonometric ratio, as it is a right angle triangle, to find the x. And you can easily say, okay, how about the tan theta, because tan theta, in this case theta is 15 degree, is opposite over adjacent, SOHCAHTOA. So adjacent, and in this case our opposite will be 500 and our adjacent will be x, which is unknown. So now if I do the cross multiplication, it is x equal to 500 over 10 of 15 degree, right? 10 of 15 degree. And if I do in calculator, yeah, it will give you 1866.02 meter, and it's asking for nearest meter. You can just write down 18.1866 meter. Okay, so that's how the angle of elevation, you can see that angle is we are creating from the horizontal line, right? Look at another example. Let's say we have another problem, which is the angle of depression from the top of a 25-meter tall tower. So it means we have a tower here which is 25-meter tall tower, and you are looking at angle of depression from the tower. So it means we know that observer is here, oh, okay, from the top of the tower, and angle of depression again is going from the horizontal line. So you have to make a horizontal line from the observer point here, and then the angle of depression 25-meter tall to a crocodile on the ground 62 degree. So it means the angle of depression here, which is will be coming to the ground. Let's say this is the one. So let's say this is our right angle triangle. So this is on for your benefit. So you have to draw for your own benefit. So you have to draw a right angle triangle with the given information. So in this case, angle of depression, you see the from the horizontal line to the depressed, so it's a measure down, and at that point, because our observer is on the top of the tower and the crocodile is here, so let's say this is our crocodile in the ground C. Again, I can just put A here. So AOC is the right angle triangle where we have angle of depression 62 degree. So if you know this is 62 degree, you can easily write down this is also 62 degree. Why? Because they are alternate angle. Because that 62 degrees outside the triangle, we need to bring or we need to know an angle within that triangle. You can also think, however, sir, we can take this angle. Yes, you can take this one also, 90 minus 62. Okay, whatever it is, you can, it's like a 28, so you can put 28 degree here, and then draw, and then with the 28 degree and 25 meter, you can also get the information whatever is asking for. It's asking for find the direct distance from the top of the tower to the crocodile. So direct distance from the top of the tower to crocodile, so it's asking for this distance x. So OC basically is asking for. Okay, so now we are using just 62, not 28. So 62 degree and 25, and we need to find out x. So x is our opposite, we know, sorry, x is our hypotenuse, because it's opposite of 90 degree, and 25 is our opposite of 62 degrees. So its opposite is there, and then hypotenuse is there. That's hypotenuse, right? And that is our opposite of 62 degrees. So which trigonometric function gives the relation between hypotenuse and opposite? We know that sine theta, in this case 62 degrees, sine theta equal to opposite over hypotenuse. I can just straight write down, so so O over H, so which is 25, opposite over hypotenuse is x. So again we can just solve for x equal to 25 over sine of 62, and if you put in calculator, it will be 25 over sine of 62 will be 28.31 meter, and if you asking for to the nearest meter, it would be 28 meter. That's it. So all about, we need to understand what is the angle of depression and angle of elevation, and you have to understand that the angle of depression and elevation always the angle based on the horizontal line, and the angle is forming at the where the observer is sitting. Okay, that's the important part. And then we need to visualize it and draw a right angle triangle, solve it by using the trigonometric ratio. uh, Thanks for watching. If you'd like to see more up-to-date videos, please subscribe my channel.